Hello, everyone. Um, this slide, this module is to solve this simple question, um, and also by reviewing some of the concepts uh, and understanding about wireless communications. So, question is, in cell phone communication, if the frequency bandwidth is 20 megahertz. That is usually the bandwidth for 4G, 3G in our case. And then another assumption here is 32 multi-level channelings and uh, signal and noise rate is 30 decibel. So under that assumption, what is the channel capacity? In other words, what is data rate? Data rate. How many the bits of data can be transmitted per second. All right. As you may know, there are two um, two approaches proposed, right? Let me bring that up. Okay, I need to do it this way. And then Nike is the bandwidth approach. The general formula is this: given bandwidth B, and if we know the level of modulation, multi-levels, then the speed is, or data rate is 2 times bandwidth times log base 2 and multi-level. All right. If there is no multi-level, simply if we have voltage, 0 voltage by voltage of encoding, um, actually this is 2 level, right? By level. Then if we put there number 2, then log base 2 will be 1. So that'll be 2b. Okay, so roughly, if our given bandwidth is 3500 hertz, then speed is 7000 bit per second. Okay, which is about 70 byte per second, which is very, very slow. Right? Back to our example, if that is 20 megahertz, then there's 20 million times 2, then 40 million. So 40 megabit per second. Okay, what it means is that 4 megabyte per second, um, roughly. But if we have a multi-levels, then the data speed will be multiplied. Okay, basically that is what it is. The other approach is signal to noise ratio approach, that is Shannon formula. So given bandwidth B, and if we know signal to noise ratio, then we apply to this logarithm. Okay, the SNR is not decibel. In our example here, decibel is given, so we need to convert that to SNR ratio, which is this. This portion is SNR, right? This is SNR only. So what it does is that if this is SNR given decimal, say X decimal, then SNR can be this is a 10 to, we divide both sides by 10, then x over 10, right? And then we make this exponential 10, then this will be canceled, which is 10 to the power this. All right, that is SNR. So in our case here, if we use Shannon approach first, for example, Shannon, according to Shannon, then SNR is 10 to the power 30 decibel divided by 10, which is 10 to the power 3. Okay, then this is 10 to the power 3. So that is a logarithm 2. So bandwidth times logarithm 2. So the data speed is this is 20 megahertz. So 20 megahertz, 20 million times logarithm 2 to the power 1000, right? Which is 20 megabytes, is 20 million times log base 2, 1000 is 2 to the power 10, right? So this will be cancelled. That is simply 10. Then 200 megahertz, which is 200 megabps. That's what we can find from Shannon. On the other hand, if we want to apply to Nyquist approach, that is that we can use this multi-level case. Data speed there, Nyquist. Oops. Nyquist. Go back to 2 times b log base 2 m. So that is data rate, data speed, data rate actually, it's rate, right? Is 2 and m, which is 32 times log base 2. Oh, I'm sorry, this should be b. Log base 2 to the power m, right? This is 2 times 20 megahertz times log base 2 m, there's a 32. 32 is 2 to the power 32, I think 5, right? 2 to the power 5. Okay, so this will be cancelled. That'll be 2 times 20 meg times 5, which is also 200. 5 times 2 is 10, so 20 here, so 200 meg. The same 200 megabps, right? This is it for the computation. If you want to obtain for the data transmission. Okay, so data transmissions highly rely on the bandwidth. Bandwidth. If we have wide bandwidth, then we can send more data, right? Even the bandwidth, if we can modulate more data, if we can modulate very high uh, data sets, right? Deeper, something like that, then we can carry more data. In other words, we can differentiate data from data to another, right? So that depends on uh, the multi-level. The other one is if we have uh, high signaling and small noisy, then also we can have higher data rates. All right, that is it. Hope you understand. Thank you.